I think one of the great challenges is really to bring together two cultures that have been separate so far, and I think even up to now most biology students don't have a formal education in maths, and physicists or informaticians, computer scientists do not know biology, and I think that is really true on all levels, and I think one of the most effective remedies for this is to really form pairs of experimentalists and theoreticians, and I think a summer school like this is just great.
The most exciting things happen when people accidentally meet, and over a beer one says, wait a second, this is what it means. And I've seen this happening, and I think this is why it's important. It's impossible to do science just by reading papers. Like in Soviet Union, we had papers, but it was very difficult to do science because you just cannot discuss it.
One of the things we're talking about today is really the language barriers and the different expertises that people have, and actually I think trying to get people familiar with each other's techniques helps enormously, and also I think it helps set expectations. I think that's one of the problems with the different disciplines.
So everybody has a lot of expectations of the other disciplines that are possibly unrealistic to start with. Everybody needs to think about the wider issues. It's very easy to forget about those when you're sitting in your lab or your office behind your computer. So I think getting everyone out of their own environment and together talking about things they don't normally talk about just highlights all of the things that everybody has to deal with.
We need interdisciplinary teams to work together, and by there are a lot of barriers to bring them together. And one of these barriers is language and culture and logic, which may be very similar. And the other one is that people are a bit scared of each other because they don't want to look like less smart. This first barrier would be to get people to be just friendly to each other and say, okay, you know something what I don't know, but I also know something you don't know.
You really need to have the data producer, the experimentalists, to understand the importance of managing the data. And there are often many places like this, many schools or many courses. People tend to find it boring because, you know, it's just storing data, it's not fun, it's not science. I think it's very important. So I think you should keep repeating and doing these courses.
I think the key ingredient is the desire on both sides to find an answer.
It's willingness to understand each other.
People have to learn very much from the other sides, and that's, to me, is the most important.
I think a willingness to learn on both sides. If one person thinks that the other person is there to serve them, then it's not going to work. I think you have to respect each other's areas of expertise.
It's not only something that is different between modelers and systems biologists and experimentalists. You can take a family and say, what's common goal? Is it for wife and a husband? Is it common goal to raise children? And that this is what they're supposed to do. Then the goal defines what. If the goal is to say, well, I'm more important than you are, then you have a completely different situation.
I think that's it really, is communication. I think that's the key thing, is for people to keep talking with each other and meet frequently and just kind of, because it's just trying to be aware of each other's problems.
A programmer does not go to a biological meeting and vice versa. And yes, I guess you tend to work with your peers, the people close to you in your institute. You don't tend to go outside and link up with many other people. So, but yeah.
I think this classic thing of language barriers. I mean, for me, I'm always amazed about how in different disciplines people use the same word and they mean completely different things. You know, a very common word. I mean, a good example is state. Biologists talk about state, and they mean, for example, the phosphorylation state of a protein. If you talk to a computer scientist about state, who might be doing some kind of model.
I was told the other day at dinner that there were too many acronyms in my talk, but I then pointed out that there are just as many acronyms in everybody else's disciplines, and I had some examples.
But I think the major barriers that I can see are educational, and they are rooted very deep in the undergraduate education of the subject. Of course, I would think it would be nice to see even more institutions like systems biology institutes.
The mathematical training of your average biologist, myself included, is not nearly good enough, I think, for to help with systems biology and modelling. I mean, the concept of a system of ordinary differential equations is completely alien to your average biologist. So you really have to have a kind of understanding, not very deep understanding, but just a working knowledge of these these things, really, to understand.
Young generation of bioscientists that are quite different. I mean, where you see that people become much more quantitative, they really want to learn mathematics. That's quite different from when I studied in terms of the biologists. And also on the other side of the physicists. I mean, traditionally physics has nothing to do with biology, but now they really become very interested.
In the project I'm involved in, the people are geographically separated from each other. So we have a lot of communication, telephone, email, Skype, but it's very different than face-to-face.
We're actually trying to have people working together in common sites, and it can really be quite difficult in terms of the bureaucracy can find that kind of difficult to deal with, you know. So those I think are the kind of challenges, and I think it sort of probably requires some kind of more original thinking.
I would not come to meetings, including this one, if my goal would be only to give a lecture. I think I just find this is an essential part of doing science, and perhaps many other things. If there is no chance of meeting someone, you don't meet them. Like I met several people here. I mean, I'm really happy that I had a chance. I didn't know that they exist.
We were discussing, I was presenting some of our problems that are related to our own research, and I tremendously enjoyed the discussion and even got some good suggestions for our actual work.
First of all, I've seen how far the field has come just in the last year, so I'm really pleased with the way that things have been coming together. And also it gives me a good chance to catch up on all of the other developments that I don't use day to day, but I need to be able to tell other people about.
I have learned a lot of people which I will keep contact and learn more from them.
For me, it's been great just kind of again hearing people discuss these kind of issues, and actually a real sense of enthusiasm. Actually, it's been great to do, presenting Edinburgh Pathway Editor and getting feedback from people, really constructive suggestions of what they'd like to see done, and also just seeing people enjoying doing science. It's been really quite encouraging, really great.
It was definitely very inspiring, and I had some very productive discussions, especially with modelers.
It's very important in science linking the people. So now I would say have about 5 contacts.
Tools that were presented here, a couple of ideas, especially in systems biology, how that differs, for example, from the field of evolutionary biology that I'm working in.
I have learned a lot about what are the point of views from biologists, bioinformaticians, and people who work on databases.
I got the feeling I'm not alone with my problems.
And I just really learned that you really need to talk a lot modelers and experimentalists to be able to communicate well. You just need to communicate.